Well, let's look at my favorite example of a ball again. So this ball, this time with a difference. Instead of a perfectly smooth floor, my floor now has friction for a change. Okay, so this is a rough floor. So I have this, I'm going to give the ball a kick, just a short, hard kick. Okay, so the ball then starts moving along the ground after I kicked it. And let's say that it starts moving at maybe 10 meters per second. Okay, starts moving at 10 meters per second. But because of the friction, at first the ball might be moving quite fast, but then because of friction it slows down and then it stops. Okay, it slows down to a stop. Right. Stopped. Let's see, let's just stop down here. Stopped. So, what's the question? Well, what is the question indeed? Now I'm going to make up a question, right? Let's say the question is this. Let's say that I'm given that the friction, we are given that the friction is the frictional force is, let's say, 2 newtons. All right, let's say that that's given. So the question is to find the time. To find the time taken for the ball to come to a stop. Okay. We need one more bit of information. So, let's say we are also given that the mass of the ball, is, say, 0.5 kilogram. So we should have all we need. Now we can do this using the acceleration equation, F equals to ma, but I'll do that in a moment. But before that, I would like to do this without sort of using the equation directly. We're just going to use the ideas of the equation to have a closer look at what kind of thing is going on with the forces and velocity. So first of all, notice that the force is in the opposite direction to the velocity. I mean, it's friction, right? So of course it's in opposite direction. And because the force is in opposite direction to the velocity, the ball would slow down. Okay. Now remember that force from our equation F equals to ma. We know that acceleration is always in the same direction as the force. So this means that our acceleration, the acceleration A, is also to the left. And if the acceleration or the force are in the opposite direction to the velocity, it causes a deceleration. The velocity slows down, right? So if you think about it this way, let me do this in maybe 2 steps. I'm going to first say that think about finding A. So from this equation, I know that A is equal to force over mass right? The force is 2 newtons, mass is 0.5 kg. So 2 over 0.5, that would be 4. Acceleration as units of meters per second squared. So that's our acceleration, but actually it's a deceleration. I'll make a note of that. It's actually not causing the ball to go faster, it's causing it to slow down because it's in the opposite direction. So it's a deceleration. Now, how much does it decelerate? Well, it decelerates by 4 meters per second every second. Okay, that's quite a mouthful. What it means is that in each second, 1 second, the velocity decreases by, right, decreases velocity by 4 meters per second. Okay, so that's how you understand this number physically. Now let's go to the question. We have 10 meters per second at first. That's the velocity of the ball just after I kicked it. And after a time t, it stopped. Stop means that the velocity goes to 0 meters per second. So that means that there's a decrease in velocity from 10 all the way to 0. So a decrease in velocity by 10 meters per second. Now, from my calculation here, I have just found that each second, the velocity would decrease by 4 meters per second. So the question now is, how long does it take for 10 meters per second to decrease to 0? And the way to do it, well, if I just do it mentally, I would think, right, after 1 second, it decreased by, the 10 decreased by 4, right? So that's 6. After another second, decreased by another 4. All right, 10 decreased by, in 1 second, 10 decreased to 6, because it has to decrease by 4. So in another 1 second, it decreases, in another 1 second, it decreases by 4 again to 2. So how much time would it, more time would it take to decrease to 0 meters per second? Well, 1 second decreased by 4 meters per second, so it'll be half a second. So 0.5 second, in another 0.5 second, 2 will decrease to 0. So clearly it is 1 plus 1 plus 0.5, and t has to be 2.5 seconds. Or I can just take 10 divided by the 4 meters per second, and I'll get, yeah, I get 2.5 seconds as well. So we can do it directly just by thinking step by step of the physical situation and relation between these quantities: velocities, time, acceleration, force, and so on. That is a very good way to do it, and in fact it can be very fast once you if you have, you know, very specific problems like that. Now it's a good way for the understanding as well. Now the next thing that I'm going to do is I'm going to show another way of doing it, which is to, if you like, just apply the equation brainlessly without thinking. Okay, just plug numbers into it. Very mechanical, but it can also be quite fast. All right, but we have to make sure that we observe all the rules and signs and so on and so on. Okay, so let's have a go at that. Now remember that the time is 2.5 seconds, right? So I'm going to write it down here as my answer. T is 2.5 seconds. Okay, so I've already got this answer. Now I'm going to clear this out. Probably easier if I clear this whole lot. Okay, 2.5 seconds. I'll just write out the answer here. Again. So let's go back to the equation. F equals to ma. How can we use this directly? Okay, I would need to relate this to the velocities. So I would have mass times A, which is V minus U over T. Alright, and the next thing that I need to do is to decide on the signs. Should I call the right side plus or minus? Okay, I'll just call it plus, and the left side will be minus. Okay. Alright. Now then I need I need to start substituting numbers in here. So let me just make clear what numbers go into each of this. So F, right, that would be F. F would be the 2 newtons. M would be the mass, 0.5 kilogram. V, when it has stopped, that's the V. So V is equal to 0 actually. 0 meter per second. U would be the starting velocity, which is 10, and T is our unknown. Right. The signs. Okay, we need to put in signs to all those quantities that have directions. So U has direction, and it's to the right, and to the right is plus. So it has a plus sign. V 0. No, we don't need a sign for that. F, now force is pointing to the left, so it has a minus sign. Can't really tell from here. Minus sign here for the force. Right, that's better. And M, we don't need a sign. T, we don't need a sign. So there we are. And we have to find the T. So my equation would be this. F equals to this. I'm going to use this directly. I'm just going to skip the MA part because I want to relate to the velocity. So, and it is the time that I want, right? So it is the time. It is this time that I want. So I want to make T the subject. So I can just cross multiply the F and the T. Okay. Or I can say I multiply both sides by T and divide both sides by F. So in either case, this is what I'm going to get. I'm going to get T on the left, and F comes down to the bottom on the right. Over T. No, over F. So that's our algebra here. Just exchange T and F. And yeah, you can start substituting numbers now. So M is 0.5. Okay. 0.5 times 0.5 times, let's see what we need. Okay, U is 0. So I substitute 0 for the U minus, 0 for the V. Okay, U is plus 10. So minus plus 10 minus plus 10. I'll just make a bracket there just to be safe, because this can sometimes be minus. So F, right? F is minus 2 newtons. So the bottom we have a minus 2. I'll put a bracket around that as well. Now, so I have all the numbers now, and I'm ready to find an answer. Okay, so I'll start by removing the bracket. So 0.5 times 0 minus 10. So that's minus 10. Bracket around that. And I still have minus 2 at the bottom. Okay, and I have minus over minus. So become plus. 10 over 2, that's 5. So cancel 1 there. Cancel, gives 5 on top. And 5 times 0.5 is 2.5. And since this is time, we have seconds. 2.5 seconds, the same as the answer that we got just now. So this is how we can do it. Okay, just first by assigning either plus or minus to one side, and then giving the signs to each of the quantities that have directions like u, f, and v, and then plugging everything or rearranging the equation to make t the subject, plugging in all the numbers into the resulting formula, and then doing the calculation. So this is a very systematic way. Well, I call it brainless because it's systematic, but it's not actually brainless. You do need to think quite hard about what numbers to use and what signs to give.